Hello everyone, welcome back to our channel. In our previous sessions, we learned about different automotive sensors and where they are installed in various vehicle systems such as the powertrain and chassis and body electronics. Today we are going to discuss another very important concept related to automotive electronics called electromagnetic compatibility, commonly known as EMC. Modern vehicles contain hundreds of electronic devices that operate simultaneously. These include sensors, electronic control systems, communication networks, infotainment systems, electric motors, battery management systems, cameras, radars, and many other electronic modules. Since all these devices operate using electrical and electromagnetic signals, there is always a possibility that one device may interfere with another device. This unwanted interference can cause incorrect sensor readings, communication failures, or even malfunction of important safety systems. Imagine driving a vehicle where the ABS suddenly stops working because of electrical noise, or the airbag ECU receives incorrect information due to electromagnetic interference. Such situation can become extremely dangerous. This is why automotive manufacturers pay special attention to electromagnetic compatibility during vehicle design. In today's session, we will understand what electromagnetic compatibility, why EMC is important in automotive, and source of electromagnetic interference, applications, where EMC is essential, international automotive, and EMC standards. By the end of this video, you will understand why EMC has become one of the most important requirements in modern electric vehicles or modern electric domain. So let's begin. Before understanding electromagnetic compatibility, let us first understand the meaning of electromagnetic interference. Whenever an electric device operates, it generates electromagnetic energy. For example, electric motor, alternators, ignition coils, high voltage cables, mobile phones, all produce electromagnetic waves. If these electromagnetic waves affect the operation of nearby electronic devices, the phenomenon is called electromagnetic interference, or EMI. Now comes the role of EMC. Electromagnetic compatibility means that an electronic device should perform its intended function correctly in its electromagnetic environment without creating interference for other devices. In simple words, we can say a device should not disturb other electronic systems. At the same time, it should not be disturbed by them also. This balance between emitting and resisting electromagnetic energy is called electromagnetic compatibility. Let us understand with an example. Suppose you are taking on your mobile phone while sitting inside a car. Even though your mobile is transmitting radio signals, the engine ECU, ABS controllers, airbags, navigation system, and dashboard display should continue operating normally. Similarly, the vehicle's high voltage electric motors should not disturb GPS signals or wireless communication. If all systems operates without affecting one another, then the vehicle has good EMC. Now let us discuss why EMC is important. First one, prevent sensor malfunction. Modern sensors measures very small electrical signals. Even a small amount of electrical noise can change the sensor output. Incorrect sensor readings may lead to wrong engine control decisions. Therefore, EMC protect sensors from unwanted interference. Second one, improve communication reliability. Vehicles use communication protocols such as CAN bus, LIN bus, FluxRay, Automotive Ethernet. These communication networks continuously exchange data between ECUs. Electromagnetic interference can corrupt these signals. Proper EMC design ensure reliability and reliable communication. Next one, reduce electronic noise. Electronic noise can originate from motors, switching circuits, alternators, and high frequency converters. EMC techniques reduce unwanted electrical noise through shielding, grounding, and filtering. These three parameters are reduced EMC or unwanted electrical noises. Next one, ensures passenger safety. Critical safety systems such as ABS, airbag, electronic stability control, autonomous driving systems must always function correctly. Any electromagnetic disturbance affecting these systems would lead to accident. Therefore, EMC directly contributes to passengers' safety. Next one, meets automotive standards. Every vehicle manufacturer must satisfy international EMC regulations before launching a vehicle into the market. Without EMC certification, automobiles can't be commercially sold in many countries. Thus, EMC not only a technical requirement but also a legal requirement. Now let us study the major sources of electromagnetic interference found inside modern automotive. First one, ignition system. In petrol vehicles, the ignition coil generates extremely high voltage to produce sparks. These rapid voltage changes create strong electromagnetic field that can interfere with nearby electronic circuits. Next parameter, electric motors. Electric motors are widely used in power steering, power windows, cooling fans, electric seat adjustment, and electric vehicles. As the motor rotates, it generates electromagnetic noise that can affect nearby sensors. And next one, inverters. Electric vehicles use high power inverters to convert DC battery voltage into AC voltage for driving electric motors. These inverters also switch thousands of times in every second. High frequency switching produces significant electromagnetic emissions. Therefore, inverter shielding and proper cable routing are essential. Next one, DC to DC converters. Electric vehicle contains DC to DC converters that converts high battery voltage into 12-volt power supply. Rapid switching inside these converters produces electromagnetic interference. Proper filtering is necessary to minimize these interferences. Next one, using mobile phones. Passengers frequently use smartphones inside the vehicle. Wireless communication such as Bluetooth, Wi-Fi, 4G, 5G, 6G also generates electromagnetic signals. Automotive electronics must remain immune to these external electromagnetic sources. Next one, high voltage cables. In electric vehicles, we have contains arranged colored high voltage cables carry hundreds of voltage. If these cables are not properly shielded, they can radiate electromagnetic energy, affecting nearby electronics. Now let us see where EMC is particularly important. First one, BMS, battery management system. It continuously measures cell voltage, current, temperature. Since these signals are very small, electrical noise can produce incorrect battery measurements. Good EMC design ensures accurate battery monitoring. And another one is advanced driver assistance system. It uses radars, cameras, ultrasonic sensors, LIDARs. These sensors require extremely accurate data. This electromagnetic interference can reduce object detection accuracy. Therefore, EMC is essential for reliable ADAS. Next one, airbag ECUs. The airbag electronic control unit must respond within milliseconds during a collision or accident. False triggering or false miscommunication errors due to EMI would become life-threatening. Hence, EMC protection is mandatory. Next, autonomous vehicles. Self-driving vehicles can contain hundreds of sensors operating simultaneously. Without proper EMC, sensor fusion may receive corrupted data. This may result in poor decision making. Next, now let us discuss important EMC standards. First one, CIS PR25. This is international standard, specifies limits for electromagnetic emission generated by vehicle electronic component. It ensures that one electronic device does not interfere with another. Next one standard is ISO 11452. This standard specifies immunities testing. It checks whether automotive electronic equipment can continually operating correctly when exposed to external electromagnetic fields. Next, another one is ISO 7637. This standard deals with electrical disturbance transmitted through vehicle power supply lines. It evaluates whether electronic system can withstand voltage spikes produced during vehicle operation. These standards ensure that automotive electronics remain reliable under real driving conditions. This figure illustrates the concept of electromagnetic compatibility inside a modern vehicle. Notice that multiple electronic systems operating simultaneously. The electric motor generates electromagnetic fields, high voltage cables carry large currents, wireless communication systems continuously transmit signals, numerous sensors measure different physical parameters. All these devices are located very close to one another. Without proper EMC design, these electronic systems would interfere with each other. To overcome these problems, engineers use several EMC techniques. These include shielded cables, proper grounding, twisted pair wirings, EMI filters, ferrite cores, metallic shielding, PCB layout optimization, proper component placements. These techniques are minimized electromagnetic interference while ensuring reliable operation of every electronic systems. As automotive technology advances towards electric and autonomous vehicles, Maintaining electromagnetic compatibility becomes even more important. A vehicle may contain more than 100 electronic modules communicating simultaneously. Therefore, EMC is no longer an optional design feature. It has become one of the fundamental requirements for building safe, intelligent, and reliable automobiles. Thank you. Thank you for watching.